Welcome back to another video. So in this video we will be seeing a new experiment, that is software defined radio active learning module, which is basically for the engineering graduates where they're studying in their communication laboratory. So this is the latest experiment introduced under KTO University. This experiment is quite new. So once you buy this particular software radio active learning module, then only you can able to do this experiment in the lab. So purchasing this software module, this software radio SDR radio is very much important to do this experiment. So in our campus, we purchased the software defined radio platform from Starcom company. They have implemented the entire module in our campus. So let's see how what is about this software radio platform. The name of this particular device is Adlam Pluto, that is the SDR device. And so this is basically a low cost portable self-contained RF learning module, and this is very cheap actually in terms of software defined radio. And this is basically based on analog devices, and the chip inside is AD9363, which is a integrated IC module, and it can covers the RF ranges from 320 megahertz to 3.8 gigahertz. By doing some proper crack, we can make use of this module from 70 megahertz to 6 gigahertz. That is also possible, and this device is capable of producing an instantaneous bandwidth of 20 megahertz. And we have 12-bit ADC and DAC is available, and it contains one transmitter module and another one receiver module in the same device. So it can able to transmit and receive signals, which basically work as half duplex or full duplex. And we also it provides GNU Radio Sync as well as source modules are available, and it support C, C++, Python APIs. And this device is powered by USB 2.0. We have two USB connectors available in this SDR module. So as you can see, this is the device interior structure, what is inside this particular SDR module. You can see we have two this transmitter. One is the transmitter where we'll connect. It's portable, you can connect it and you can take it off once not required. So this is the antenna session where you can connect a transmitter antenna and the receiver antenna. And you can see the main integrated chip AD9363 is over here, and we have two USB ports, which is here. One is used to power the device, the other one is used to for the data syncing purpose. And this is the different block diagrams that includes in this particular SDR platform. So in order to make use of this particular SDR device, we need a software backup in the system. So the software that support this particular SDR is GNU Radio Companion, which is an open source free software development tool for signal processing and radio applications. So it is a graphical tool for creating signal flow graph and generating flow graph source code. So it provides signal processing block for radio implementations, and which is compatible for both Linux and Windows versions. And for Windows, it starts supporting from Windows 10 onwards. So this is all about the introduction to software radio device, that is Adlam Pluto, and the software component, that is GNU Radio Companion. Let's see how this device can be connected and how this work for an FM transmission and reception experiment. Okay, so to start with, you need to connect the SDR platform to the computer, and also you need to install the software, that is GNU Radio Companion. You can see over here GNU Radio Companion. So click on that, the software start work up, and once the complete software is launched, you will get an interface like this. So this is the interface of GNU Radio Companion. And so first thing is we're gonna do FM transmitter, and we'll transmit a signal from your system, and SDR is connected. So SDR having a transmitter antenna, and which will transmit the signal. So we need to give an input signal, that is I'm going to give an audio file in the format of .wave format. So we will browse a audio file in wave format, and that will be given as an input to this FM transmitter block. We have a number of blocks are there, like wideband FM transmitter block, followed by multiply constant block, rational resampler block, and a GNU Radio Sync block. So these are the different blocks included in a FM transmitter sessions of that we going to implement in this GNU Radio Companion. And once we start simulation, what happens, this audio signal will be transmitted, and we will set some local oscillator frequency, maybe it will be around 90 megahertz. So this entire audio signal will be transmitted to that particular frequency, that is 90 megahertz. So we have two options to receive this file to test this experiment. Like the other one is that turn on radio in your mobile phone, and you can able to tune to 90 megahertz, so that you can able to hear the signal that we send to the SDR module will be, we can hear the same signal, the same song or same sound in the mobile phone when we tune to 90 megahertz. Or else the second option is that connect the SDR module, one more SDR module, to a next system where we implement a FM receiver section block, and we will be connecting a speaker to the computer, and we start simulation. Then what happens, the SDR start receiving the SDR, the receiver SDR also tuned to the local oscillator frequencies tuned to the same 90 megahertz, so that the transmitter SDR is in 90 megahertz, the signal will be received by the SDR receiver for the same 90 megahertz, and which will be like processed in the computer itself, and we can able to hear the output signal in the speaker of the computer. So this is the second thing. So this is the entire setup of this FM transmitter reception experiment. So first I will show you the block diagram of FM transmitter. So this is the block diagram. We have a source file, a .wave source file block is there, followed by WFM, that is wideband FM transmitter block. We have some audio frequency rate is there, 48 kilohertz, and then quadrature rate we need to fix it. Then we have a multiply constant block, we have a rational sampler block, followed by then SDR sync and GUI sync. This is the entire block of your SDR transmitter. So I'll show you how to connect all these block in a quick manner. So first you need to go to the search bar here, click on the search bar here, you have the search bar, then search for wave, that is the wave file source. That means we can able to give a audio wave file, okay, in the format .wave format. So double click, that will be here. Okay, so fine. So wave format is here. Let me move this to other side. Fine. So the next block is a wideband FM transmitter block. So go here and search for WD, that is wideband FM. Okay, so type WBFM, so wideband FM, and you can see the WBFM transmitter module. So just click on here. So that's it. Now this is a wave file source is the input, and this is the output. So you can connect it. Click on this area, this is out, and click on this area, this is in. So automatically it will be connected. That input and output will be connected. The wave file source is the input, and that the output of that is connected to the input of the FM transmitter radio wideband FM transmitter. So here you need to give an audio file. So double click on wave file source and browse. You need to give an audio file which is in wave format. So in my downloads I have the file. You can see here example file which is in .wave format. It's an audio format in wave format. So select that. Okay, so the path is selected and click OK. So I have connected, I have given the source file as an audio signal in .wave format. And in this wideband FM transmitter, what it do means it take a single float input stream of audio signal and it's produce a single FM modulated complex baseband output. That's what this wideband FM transmitter do. So for that we need to have some specification for the FM transmitter module. So we need to give some specification. So double click on that and you need to give the audio rate as 48k, that is 48 kilohertz. Okay, so and you need to give the quadrature rate as 192 kilohertz. That's it. Click apply. Okay. Fine. So this is done. So once we complete that, then we go and search multiply constant, which is in the library. So select it. That's it, multiply constant. So multiply is what this particular block do means it multiplies the input stream by a scalar or vector constant. So it simply multiply with a constant value. So the operation working is the output of the wideband FM transmitter will be multiplied with a constant, that will be the output of the multiply constant. Okay, so I'm going to connect these to each other. So this is the output block and connected to the input of the multiply constant, and I need to give the value as 500. So set the value as 500 constant value and click OK. Yeah, that's it. Once this process is completed, now we go for the next block, that is rational sampler. So rational resampler. So what is rational sampler? What this block is doing here? So rational sampler, it is a process of converting a sample rate of a signal to another sampling rate that differ from the original sampling rate of a rational, like original sampling rate of the signal, and by a rational factor of L by M. So that's what it does, and this L by M is nothing but two integer sample values. So what it does simply interpolation and decimations. Okay, so what the output of this multiply constant, that is multiplied by 500, that is connected to the input of the rational sampler. So it interpolates, that means multiplies the sample by rate of 500, and decimate, that means divides by a value of 960 to produce an output sample rate of 500. That's what's all about doing by this rational resampler over here. Then once it is completed, the next block will be your PlutoSDR Zynq, that we can take it from the library again. You just type PlutoSDR Zynq. Okay, so select it over here, and also for graphical UI GUI I need GUI Zynq, Qt GUI Zynq, that also required for the visualization of the graph and all. So when both are connected, let me connect the output of the rational resampler to the input of the PlutoSDR, and also the output of the rational resampler connected to the graphical user interface Zynq. So this is the entire block of the FM, and also as I told you, once you wanted to send this particular signal, that I selected an audio file here in the .wave format, that will be undergoes these different blocks and finally transmitted. So the transmitted here, then we need to define the local oscillator frequency. Suppose this currently it is 2.4 gigahertz, so it start sending your audio in 2.4 gigahertz frequency. So if you wanted to change, like you wanted to give 90 megahertz, then you can give 90 megahertz value. Let me give this value. So it 90k now. Okay, 900k, and it's 99 megahertz. You need to give 90 megahertz. Okay, so you can see here it's now 90 megahertz, and for here you need to set the bandwidth. You can, if you require, you can give here 48 bandwidth. It's 48. That's what the frequency we defined already, 48K. You can give that. And in the rational sampler, you can give an interpolation value of 8 and decimation as equal like 1. And here you can check all the values here. It's all fine. So the entire transmitter module is completed. Okay, so let's connect SDR and we can see how this process is going on. Okay, so the SDR module is here, which is Adlam Pluto, and you can see that two antennas are there. One is transmitter and receiver, and the USB cable which is connected to the CPU. So now the SDR is connected to the computer. Now let's open the software, that is Companion. GNU Companion is there, so which is just go to the start menu, and if you click on there, GNU Radio Companion is there. You can click on that, then it will be launched. Okay, which we already seen. So let's open it, and you will get the interface like this. So let me open the program for FM transmitter. So I have stored the program in one folder, so go to the file location. In our case we already created the block diagram of FM transmitter. You can draw it, or if you have a already saved program is there, like a file is there, you can open the particular folder, and this is the entire block of the FM transmitter session. The source file format, the source .wave file source is there, which is connected to, you know, like the next one, that is wideband transmitter block. Then similarly, and also this is the process where, you know, in the wave format we need to give an audio signal. So the signal should be in .wave format. So double click on that, and you need to browse a wave audio file. Then this will be taken over through all the block, and for each block we need to set the frequencies, and especially in the last SDR Zynq session we need to set the local oscillator frequency. That is a frequency your particular device is going to send. So I set it as 90 megahertz, or you can set it as 93 megahertz. Whatever frequency your SDR support, that frequency can be set over there, so that according to that frequency the signal will be transmitted from your SDR. So once you start simulation, you can see that you will get the waveform, different waveform patterns of the signal that is produced. We can see it over here in this particular GNU. This is basically produced by your GNU Zynq, Qt GNU Zynq. And you can see that the next computer I have connected the speaker, and which is connected to the 3.5 mm audio jack, and also the SDR, second SDR module, which is also connected to the computer CPU via USB 2.0. and there also I am opening this GNU Radio Companion, and I'm going to open the program in the block for the transmitter session. So let's open from the file location where I already created a block for the GNU FM radio reception session. These are the entire blocks of the reception. And so the reverse process, basically whatever the process we goes for the transmission, the reverse process will be done in the reception session. But the important criteria is that you need to set the local oscillator frequency to the same frequency as the transmitter, and you can click on the simulation start button. So what happen means your SDR start tuned to 90 megahertz and you can see the signal will be audible in the speaker. So this is the entire setup. We need two computers, we need two SDR modules and one speakers, and this is how the FM transmission and reception.